Hello, welcome to the APO Productivity Talks. This is Ted Yang from the Asian Productivity Organization, the APO. We are broadcasting from Tokyo, Japan. Thank you for joining us from across the globe. The APO is committed to fostering sustainable socioeconomic development across the Asia-Pacific region. We aim to promote innovation-driven, sustainable productivity growth in line with the UN Sustainable Development Goals. One of the APO's constant endeavors is the Green Productivity Initiative, which aims to raise productivity and efficiency while factoring in and reducing the impact on the environment. In today's session, we will place our focus onto the circular economy, which is an approach that redefines how we think about resource management, economic activities, and sustainability. Rather than the traditional linear take, make, dispose model, the circular economy emphasizes reusing and recycling materials, reducing waste, and regenerating natural systems to maximize value, which matches perfectly with the APO's Green Productivity Initiative. To help us explore this vital topic, we are privileged to have Mr. Reu to discuss with us about the concept, strategies, and practices to achieve the circular economy. Ray currently serves as a marketing manager of the Green Energy and Environment Research Laboratories at the Industrial Technology Research Institute in the ROC. As a sustainability professional for nearly 40 years, Ray has extensive experience in life cycle assessment, carbon footprint analysis, and resource efficiency management. He works closely with policymakers, industries, and researchers. He also develops databases, software, and systems that are widely used by government agencies and businesses. Today, Ray will provide insights into the practical application of circular economy principles, share methodologies and practices that facilitate the circular economy, and help us understand how we can contribute to raising resource productivity. Through a few basic questions and Ray's explanation, I hope we can understand more about what the circular economy is, why we need to look into it, and what we can do so that we can address this important issue. Ray, welcome to the APO Productivity Talks. To kickstart today's sharing, would you like to say hi to our audience and give us a brief overview of what the circular economy entails and why it is important for sustainability?
Yeah, hi everybody. I'm Ray Reu from ITRI, Industrial Technology Research Institute, Republic of China. And I worked for ITRI for more than 36 years, not long, for 40 years, okay? And I think most of my works focus on environmental management, including life cycle assessment and also circular economy. And at the first earlier stage, I work on the resource recycling, including technology development. Yeah, that will be my major work in the past 36 years and until now.
Wonderful. Thank you very much for taking the time to share with us about the circular economy. For those who are still not familiar with the circular economy concept, would you mind explaining briefly what it is and why it is important for sustainability and resource productivity?
Yeah, of course. The main reason we have to do circular economy is because the way of our life and industry will mass production and mass consumption of materials. So anything that is more than the nature or the earth can persist supporting. So we have to change that into a circular way to think. How can we satisfy our need and also saving resource from the earth or resources? That means it's a lot of things from air, liquid, and solid. A lot of things you think it is naturally you can get it from the nature, but not necessary it will provide because the resource is limited. But our need, our demand is quite unlimited. That's the problem. We have to do better. So circular economy is introduced uh, more than 20 years ago. But in recent years, circular economy become more known by the public. But, but the concept started at least 20 years ago. Okay, let me say, oops, let me say there is to explain how the circular economy work. First thing we do have to do some fundamentals like material flows. Okay, and then we have to know what's the difference between resource recycling and the circular economy. Many people think resource recycling is equal to circular economy, but it is not correct. And then I will introduce I established a platform in Taiwan uh, to make some verification and matchmaking of the material. We call it circular material. Make them circular. Started in Taiwan, or maybe in other countries will be also be good. And then I will give you some good example how this concept of circular economy goes and how this platform is doing. Okay, and the first thing is the fundamental of the material flow, and normally we have to start with the waste department because most of our material after they are used normally they are abandoned or wasted, so we call it waste, but it is really a kind of a resource, not a waste. So we have something say recycling, resource recovery, a lot of in our terms because we have to make them circulate again. So in this figure, you can see this is municipal solid waste management. We know in Taiwan, municipal solid waste generated mm, about the 10 million tons per year. You see the number here. It's a 991 from the very right. And you can see the number of the recycling rate is 62% in 2021. So it's the leading group in the world for the recycling rate. Like German, like French, like Austria, they are almost about around the 60% also a recycling rate, but many countries less than 5%. So this is very important to know what your problem is and how big is your problem and what is your status. So this is the first thing, and this is for municipal solid waste. It's come from the household, like garbage. Every family, they have to put away and to the garbage truck. And the other things is the industrial waste. Industrial waste, here's our number. The recycling rate is higher than the municipal solid waste. It's 85% in 2021. And for the past 20 years, we have increased a lot from the recycling rate. And how this recycling rate is higher than the municipal solid waste? Because we have regulation to make everybody have to have to report their waste generated, waste treated, and clean up by the contractors. So you can see this is legally requested, so it can do better than the municipal solid waste, because we have less than 10,000 of factories in Taiwan, but we have 23 million people in Taiwan. We cannot command everybody to do daily, monthly, weekly reporting, to report how their waste is generated and is treated and where they go. This is not possible. They only have to use the recycling truck and also garbage truck to collect the waste, the solid waste generated by the families. So it's the difference between industrial waste and municipal solid waste. So this is the basic one for waste, but not only waste. We have to do all the material flows, like the quantity of the merchandise, the material imported and exported, the merchandise imported and exported. You can see the figure on the up left. There is a database. We know the quantity and what kind of industry and the trend of one and another years, and to see which industry will produce material flow through another industries or other industries, because there is a lot of industry in Taiwan. So the number can go through a lot of things to do the math, to know what your problem is and how big are they, and can you treat it with something better. No, at least the know where is our material is that there's a kind of methodology called material flow analysis. And after that, we can start to manage. And maybe we can say we can digest those kind of material, especially for the waste, because the waste had to come back and become a resource again to meet the requirement of circular economy. And then we start to do our circulation, and even better, we can make more value to those material, not only material, not only the waste. It's about the waste and the material, them all. For example, fly ash used to be a kind of waste. Now can be additive in the cement or the concrete production. Okay, but it's very low value. But we know about 0.4% of the fly ash is vanadium. It's a material to do industrialized battery. So this kind of material is much more expensive than the fly ash. So if we can drag out the material vanadium from fly ash, maybe we can increase the value of the fly ash. So this is an example of how we started from material flow to do the value addition and to meet the progress of the circuit economy. And yeah, that will be the first question. That circuit economy should do step by step, to know where and how much you have, and to do how to what kind of management and to what kind of value added, and become circulation in the environment. Okay.
Wonderful. Thank you very much, Ray, for explaining to us about what the circular economy is. And I appreciate that you highlighted the importance of value, and that we need to understand what is the waste, and if this waste is actually part of resources, and how we can improve the use of our resources so that we can create more value and reduce environmental impact. I also appreciate that you mentioned that the importance of the data. You showed very crucial data from Taiwan about how you measure your waste level and what can be turned into useful resources. So I suppose that to achieve the circular economy, there should be a lot of fundamental adjustments in the supply chains, in productions, in services. But all in all, where to start? Where to start in this process so that we can facilitate the formation of the circular economy?
Yeah. Well, just as I mentioned, we have to collect the data year by year to know, especially we would do economic wide for the majority of the material. You know, in Taiwan, we import more than 300 million tons of material, not imported, import plus extraction. So we call it DMI, about 330 or 40 million tons per year. And we make some use to support our life. And also we manufacturing material and product to export to earn our money, make some GDP. And some of the material are exported. Some of the material are becoming waste. I would say waste stream, because the waste stream including air emitted and water emitted and solid waste, we have the treatment. And the majority of the material in Taiwan is the fossil fuel, and mostly we burn it. So we have about 150 million tons of fuel, fossil fuel per year. That's a lot. And after burning it, we produce 281 million tons of the carbon dioxide. We also call it greenhouse gas. And and this is the total of economic-wide of material flow analysis. This is a roughly a big number there. So you can see all the import and export, and also some are recycling. We call it as cyclical use is about 61 million tons per year. And this is only 1 year. So we have to do years by years by years. So we know, and in the 3 years ago, 2022, and we decreased the import, and also we decreased the export. Maybe become because of the pandemic, we reduced the economic activity, but it is not all true. Because we do use less, but we earn more. So you can see the difference and to see the reason why. And you can dig even deeper to direct material input. We categorize into 4 large categories. Says biomass in the top is the most, I think, support our people, food and feedstocks. And also we have import metal, non-metal, and you see only almost half of the import material is input material, not imported, input material, including extraction. It's about only about 40 to 50%. That's a lot in comparison with other countries. So you can dig even deeper to know what is how many kinds of fossil fuel we imported, how many non-metal material, how many metal material we are using in this country. So, and you can see that the resource productivity, it's a number about GDP divided by DMI or GDP divided by DMC. DMI is the direct material input. DMC is the material that you consumed in Taiwan, excluded the export. So this is the figure. We are increasing our resource productivity from about let's say GDP per DMC from $60, and now it's more than $80. We do have increasing in the past 10 years a lot of this means we earn the same money with less material we use, or we earn more money than in the same amount of material we are using. So this is the trend. If you see the trend is going up, congratulations, you are doing fine. And this is the source of our numbers. I show today here the numbers you've seen. It's all on the website. We put it Taiwan MOEMV, Taiwan Minister of Environment. They have a website. I already said that in 2015. This website still work and still alive. You can see every year, but the newest data is 2022. Maybe next month it will get into 2023, because we have to have time to digest those numbers from different departments of the government, like the Department of the Agriculture, Department of Transportation, Department of Economic, Department of Environment themselves for waste. So we have to collect all the data and integrate them together to make this kind of figure and open to the public, make everybody available for this kind of data you can receive and you can analyze in Taiwan. Any person who has interesting in knowing what kind of number they can have easily access of the this kind of number. It's very important, because not every work is by the government. Many works is done by the school, by the scholar, or by the institute like ITRI. Everybody needs data to perform their analysis and to research, to get out a kind of solution, and to research for their markets. It's a group work. It's not only government's work. Only government cannot work. I think so. Yeah.
Wonderful. Thank you very much. I think you emphasize again the importance of data about material or resources that are available, since we are talking about value here and identifying what's waste, what's resources. It is very, very important that we have enough data, enough numbers, and enough transparency and visibility about the potential resources we have. And I think you showed a very, very good job from Taiwan, that there are so many data or information available to the public. So I think that really explains where we can start when we try to approach the circular economy. But in terms of material and resource management, how do we better manage these resources if we now identify that these are potential resources, these are the materials at hand? How can materials and resources be better managed?
Yeah. To answer this question, I have to make everyone know the difference between resource recycling and circular economy. And from the right-hand side, you can see we want less the treatment, the better. So we are decreasing the waste number to treatment and become resource recycling. But these are only on waste side, only part of our material. Remember the number, we have 30 million tons of waste. And most of them, 85%, 65% of municipal solid waste is recycled. So that's resource recycling. But the really thing matters that to reduce the resource needed to support our society, our economy, is circular economy. We need some more. The most important one is new business, like a leasing model. So if you buy a computer and use it, and if you buy a bicycle. So you keep it and ride it for several months and be stolen, and you lose one bike, you buy another one. So if you're doing this, you are doing a linear economy, not circular economy. So you manufacture, sell, and use and dump. And if you get stolen, your bike gets stolen, you will buy another one, increase the consumption. But if you're leasing it, like in Taiwan, we have U-Bike as a model, they would become a very good way, because when you are using a bike, everybody using their bike only when they have the need to do that. They have the demand to do that. So that's good. That's good. And when they're not using, the bike can be easily transferred to another to use. So it's a better, efficient way to use any kind of material. A car, a bike, a cell phone. Only a leasing model can return the material back and use again and again, and by the society. So sometimes leasing is only a way of saying things. In the broader way, we can say service as a product. You are not selling bike, you're selling transportation from one point to another point. So this is the concept of the circular economy. It can reduce a lot of material need in this society. It is much bigger than the resource recycling. Although we started our circular economy from resource recycling, but now we understand to do a circular economy, to reduce the resource we need in the society, for the society, the demand side, you have to bring down the demand side. So only new business model for circular economy models like leasing service as a product. And so I would define circular economy is become a new business model plus resource recycling minus treatment, because we want less the treatment, the better. And let me take an example for different industry. We can see from bike, from cars, from cell phone, from our daily work. But these things, it's a big one, because all the material is manufactured for the society. So why do you have to manufacture a cell phone? You have to sell it to earn more money. So this is economic flow. But this is for the society. But for the industry, they also have the similar situation. They have normally, for example, for electricity, they generate electricity. So in the power plant, they generate electricity, but also they can generate fly ash. Used to be a waste, but the waste now can be their concrete, a part of concrete. So it go to the concrete market and compete another material like a cement. And also we have in Taiwan, we are famous at electronic manufacturing, especially a semiconductor. A semiconductor is produce a lot of calcium fluoride sludge. That's a lot, more than 100,000 tons per year. So that's a lot of, but it can be the input of the cement. So if they know their material, their composition is suitable for the cement, it will be good to know that, and the cement king is willing to accept them as their material, rather than to buy from a much more expensive way in another place. And also, this kind of sludge can be used as a temperature reduction agent. So in the steel manufacturing company, and the steel manufacturing, the steel produce slag. Slag also can be an input of cement, and also be an input of the concrete markets. So these are industry are together. So in this way, I would say this is industry to industry, plant to plant, or factory to factory. And different kinds of industry can help. One's waste can be another's material input or raw material. So this how things work. You have to find out where is where. And the other way is we have a kind of eco-industrial park. Eco-industrial is also the same concept. Because we have several industry in eco-industrial park, you have to arrange the kind of, they have the synergy of the kind of calcium fluorides they can use as semiconductor manufacturer, and that can be an input for cement or input for steel company. So this is a very good way to think the symbiosis of different industries. Okay, this is the first thing we should know. And then we know that it's only a way to do that. You have to think about the capacity and the demand. You have to balance the demand side and the supply side. And we have such a supply side. It's mostly exclude the 40 surplus soil from construction industry. What I meant is 30 million tons of waste generated in Taiwan. You have kind of things like 5 million tons of coal ash, 2 million tons of inorganic sludge, and a BOF slag is 1.6 million, and a lot of things. And this is inorganic. And also we have some organic waste. So we have farming waste, kitchen waste, and sludge, and all the things here. So we have to arrange if they can use this kind of material. So you have to know what is the capacity of, what is the potential capacity of this kind of facility or industry. For example, for the cement kiln. Cement kiln in Taiwan, we generate about we produce about 10 million tons of cement per year. And according to the ratio, 10 million tons of Japan will produce, will use 4.76 million tons of waste. I just mentioned in the right and left hand side, the 5 million tons of coal ash, 2 million tons of inorganic sludge can also be an input of the cement kiln, and then produce 10 million tons of clinker and cement and go to the concrete industry. So this is the balance. You have to, how many is used in cement can, how many is used in asphalt concrete, how many is going to the waste stream for incineration and waste stream for pyrolysis, or become a better fuel for coal generation to replace coal. So this is the whole plan. You have to know where your material can go and digest and become a useful material for another industry. So this is quite important. And it's worth mention of the cement kiln. I would say it's a metabolic organ for a country. It's kind of waste filter, because most of organic and inorganic waste into the cement. For example, inorganic material like a BOF slags, they input in and become low carbon cement. How come they become low carbon? Because the 60% of the cement's carbon footprint is come from the CaCO3. It's a calcium compound, and into calcium oxidized. It's about 60% of the carbon footprint. But if you input BOF slag or oxidating slags, they are originally become calcium oxide. So they will not emit carbon dioxide, and so that you can reduce part of the 60%. So that's very good for a kind of material. And also the organic become fuel to fuel the cement kiln. And also after burning, the ash of the fuel become another material in an organic, because the ash is also the input of the cement kiln. So you save carbon emission, and you also save fuel. So that's a very good one. And you produce nothing but cement, no waste, no further waste is generated. So it is very good one. So I call it a metabolism organ, like a kidney in our human body. Yeah, that's the reason why it is so important.
Wonderful. Thank you for giving us the example of how resources can be identified and can be managed. I also appreciate that you highlighted that it can actually trigger implications such as having new business models or forming industrial symbiosis that is also going to enhance the formation of a more circular economy. I hope to extend from this as well, because nowadays, like what you were mentioning, there are also different technologies that can help to facilitate the formation of circular economy. And I suppose in terms of recycling or even treatment, technologies are playing a big important role in this process. So would you mind sharing with us how technologies can facilitate the development of the circular economy?
Yeah. Speak of the technology, because what I just mentioned is an ideal way of producing value from those waste material. But in our experience, and I think every other country also experienced that kind of situation. Yeah, we know that they can be recycled in a way, but it is much cheaper to dump illegally to the ocean or to the soil, which is no inhabitants there. So in Taiwan, we have a lot of mountains. You see in the middle of the Taiwan, in the right-hand side, it's a kind of a mountain area. Only 1/3 of the land can be used in Taiwan. So, but the mountain area is so large; it's about 2/3 of the Taiwan. So if you see that many illegal dumper just dump their waste in the mountain area and pollute the water resources and also the mountains or the forest. So we have a lot of problem in dealing with such kind of things. And even in the seashore side, where is less people live there, also have a very huge problem of illegal dumping. Because in the urban area, people there, they will not dare to dump waste there. But in Taiwan, in the past 30 to 50 years, we have treating this kind of issues and dealing with that, and to make some new regulation to make people comply with this kind of illegal dumping from the generation of the waste to start to track those kind of material. But it was very expensive for a GPS, for a camera. It's kind of expensive things, but the new technology has improved the technology and make them cheaper. So now a camera, a GPS, computer is much cheaper. So we can use them to make a new model and make a new use of the kind of function. we can record the whole time of the transportation and keeping tracking of the GPS of the transporting vehicles. So once they have their target and they go to the mountain area or they go to the seashore where is less inhabitants, and that will be a problem. So we alert at the control center. So people can alert the agency or the generation of the waste, the enterprise, to know that you have waste are illegal dumped, or doing something, or is going to do something like this. And we have an early warning of the right track is not there. They go to the wrong track. They want to go to the seashore or to go to the boiler, the incinerator, and they go to another side, like a seashore. So we have such kind of records, and the camera can provide a real-time surveillance of where they are, what they are doing, and also these materials are saved into internet in the cloud, and with the help of blockchain that will be then cannot easily be revised, and it will be always there. You can use this as real evidence to say, okay, my waste is transporting in the right way, treatment in the right way, and disposal and reuse in the right way to the right facility. So this is very important for for this technology improvement to use in this kind of things. Another thing is much more interesting is about AI, because when you're doing surveillance, you use a lot of manpower to real-time monitoring the monitor, and everybody gets sleepy because it's quite boring. But if you can have your computer monitoring this kind of things, unless there are abnormal situation happen, you get the right person to alert. Then okay, you have something to do. So this, we can save a lot of manpower using AI recognition to recognize where the transportation is, what the transportation is loaded, and how are they management in the right way or the wrong way, and how much is the transportation, even the storage is good enough, is legally or not. So this kind of material, including a database, provide a huge amount of statistic data and can help us to make matchmaking verification to do that. So we call this platform is circular material verification and matchmaking platform. So this is very, I think it's a very good one, and we are doing this and to promote this kind of activity in Taiwan. And the clouds help us easy access. The AI give us less manpower demand, and also the blockchain makes us believe this thing is real. Okay, so this is the technology we're using. And for the matchmaking of the a different material, because if you said I don't know my fluoride, calcium fluoride sludge can be used by the steel industry, for a semiconductor manufacturing company says, okay, and they can input their material input to this system, and this system will tell them, okay, where you can go and how much do you have to pay or you can get money from. So this is a huge database. So everyone can use this kind of input data to search their material, where their material can go. So this is a very good one. And right now we are using only from the inside of Yiing, not for the public yet, because we try to use much more function like AI, which is more popular, GAI, generative artificial intelligence. It's a good way to think because we have a lot of database. So that's why I mentioned material flow analysis is the first thing to do, and you can do after another things. And this kind of data is from the agriculture, energy department, and also the mining department. And a lot of government departments, they can provide the important data to this kind of matchmaking system. And because we have this kind of system, we have ability to predict the investment will increase the carbon emission or the waste generation. So we have a lot of data to do things like that. So we call this a matchmaking system. I'm sorry. And with the matchmaking system, we find out we have one kind of slag, call it reducing slag. It's much useful to cement kiln because they contain a lot of calcium oxide. So I just mentioned the cement kiln needs a lot of calcium oxide. It also, because they have mining the stone, it's also called calcium carbonate. I try to remember this name. And calcium carbonate, we produce a lot of carbon dioxide. It's 60% of the carbon footprint of the cement. So if they can use a lot of this kind of reducing slag, they would get a very large of the carbon reduction. And also, this kind of material is not easy to treat because they have a lot of bad property for inflating. If you use in the road pavement, you will expand because it absorbs water. So if they absorb water, they inflate it and become more volume. So it would produce problem when the car is riding on the roads and pavement. And we know that where is the electrical arc furnace 1, 2, 3, 4, 5 in the west of Taiwan, and the east of Taiwan we have a lot of cement kiln. So we have A, B, C, D, E, F. So we try to matchmaking them each by each to know where is the capacity. And you see the on the lower right, you see we have the capacity of the cement kiln, and also we have know that they have the ability to receive more reducing slags. So we try to make as a matchmaker to help them to digest and make it useful for another industry. So this is the matchmaking system is doing. And so far we have some potential second material. We have BF slag, okay, reclaimed asphalt concrete. We have more than 1 million tons of material. We have some lemon peel, and we have electronic grade sulfuric acid. So these on the red one is we are right now we doing in a quite successfully way, but the other is potential things we will introduce into another industry to do their best of their use. And this platform, the key point of this platform is to introduce this kind of matchmaking and verification to make sure people can do the right things, and to provide evidence of the people is doing right things to the public and make more people more confidence, because transparency is the only way to that everybody knows I am doing things legally and also will not harm the environment or in your neighborhood. So from the initial incineration and landfill, we transfer the 330 million tons total flow to the right-hand side. Hopefully, we can reduce the 330 million tons to maybe 200 million tons. That's a major successful, but not yet. We trying to do that. Okay, so this is the point of the verification matchmaking. Okay,
Wonderful. Thank you very much. The platform you mentioned is certainly significant and very, very impressive. It's really amazing that the Taiwanese government and the organizations, and industries can collaborate and form this platform. I also appreciate that you highlighted that technologies are not only used for, say, treating the materials or for recycling, but it's also largely applied in the governance of resources. For example, you use big data, you use AI recognition, cloud, blockchain, to keep records on resources or potential resources, and to enable traceability and transparency in knowing what are the resources available and how we can increase the value. That is really, really inspiring. I'm also curious that, you showed the platform and examples from an overall macro management point of view. Would you mind giving us a few more examples about the applications of the circular economy in businesses or in different sectors?
Okay. For the organic waste, in Taiwan, we generate a lot of lemon juice. And this kind of fruit is part of the Rutaceae fruit. They can produce the vitamins, trace elements, and also fiber, dietary fiber, and another things that benefit for the body, for the human body. But when we extract these kind of things, we know that the peels become waste, and they have to pay $10 million per year to treat this kind of waste, because they generate 350 kilotons per year. That's a lot of waste, and they are dealing problem with that. And we also know that in Taiwan we have a lot of bubble tea. And bubble tea, we use a lot of imported material. We just say pectin. It's a gelish material and input to the bubble tea, and that's make it more delicious to eat. It's quite famous in Taiwan. And so we try to use this kind of peel to extract those kind of pectins. So in this kind, we will produce $22 million US dollars per year. That should cover the 10 million US dollars. So that will be a good one for a lemon peel to use one. But if you can improve this kind of pectin into a smaller molecular, they will produce a medical or health food, a raw material. It less, but they about Taiwanese dollars, by 5,000 Taiwanese dollars per kilogram. So that's a lot, not per ton, not per kilogram. It's very expensive material. So this kind of health, food, medical raw material will have 1.6 billion US dollars a potential market in Taiwan. And after that, we have a lot of residual, like what's left of the lemon peel. It can be used, acidify from a fermentation, become a feedstock for the farm. And when the cattle or the goat, they eat this kind of material, they would reducing their methane gas from their emission from a farm. Okay, so this is very good way to digest all kind of the material left through all this process, and that become from the bad one, we said $10 million expense, to a good one without to treat those kind of material. We have a good one. We have potential value of 1.6 billion US dollars. So this is a good example to make use of things. You have to know what the material is, what do they what is the content in there, and then they can make and in what kind of demand, in what kind of markets. So you can see this is a good example because we have a lot of data in our database. And then the other things is the I would call it anti-routing asphalt concrete pavement. We use the natural sand and gravels to produce this kind of payments. So, and every year we have 50 million tons of payment, and also we have reclaimed 50 million tons of asphalt payment. And we also have 1.6 million tons of steel stacks, and we have nowhere to go. But we know 1.6 million, and the other is 15 millions, 10 times more. So that would be a good way to think if the steel slag can be used in asphalt concrete. So we invent asphalt concrete from another research team. So we see it can revive that and into a good payment, and they have 5-time lifespan. So this is very good one with entry-up asphalt concrete country. We can use steel slag because steel slag is melted and and very hard, very not easy to break. They have good property of their strengths. So let's support this kind of payment to make it longer last. At 5-time means that we can save natural sand and gravels. And also the carbon reduction can be more than 70%. And also the economic side, we can reduce the cost of the payment from 20% to 35%. So it's much cheaper. And also we got some R&D 100 finalist reward. Okay. And for this kind of application, we started to promote in Taiwan everywhere. First, we come from Formosa Plastics and Taoyuan City, Pingtung County. We have all kind of road and in line with our verification platform, because steel slags still considered as kind of waste. So people don't have the confidence. We have to make some verification to help people to understand this is safe and good. So we service with our blockchain, AI, and IoTs to help the whole picture come true. So this become a very good example to do that. And we'll produce a lot of digestion of the material and to a better use of the raw material and improves the product, like payment is better. So this is a very good example. And another example is about the business model. Remember I said circular economy is from the economic side and the business model. If you buy a bike instead of leasing a bike or renting a bike, you would say that's mine, so keep in, but normally you use it for 20 minutes per day. But if you're using in a leasing model, you may use it in maybe 12 hours per day. So only the same material, same amount of material, you produce a lot of value and usage to that. So that's a good way, like a copier, photocopier. They pay by the sheet copied. So this is what I mentioned, the service as a product, the serve as a copy service. So this is a good one. And this is for the domestic, about the families and or companies, office. And for the industry, especially in semiconductor industry, in recent years, we do have a lot of semiconductor industry seen by the people in the world, because TSMC produce a very good semiconductor. And because they have 2 nanometer, 1.x nanometer, 3 nanometer production, they need a lot of electronic grade sulfuric acid. And now they have reached 300,000 tons per year and increase rapidly. Maybe in few years, they will become double, because the fine, the material you want to wash, you have use more sulfuric acid to wash it and become better efficient, better production process. So at the first, they go to the waste treatment and use as industrial grade sulfuric acid, but the market of the industrial grade market is full. So the demand is much less than supply. So they have problem with the digestion of this kind of waste. And the other thing, they come up with the second circulation. They think, okay, if it is not good enough, we can beside from the industrial grade acid as a digestion way, and we can do add some also the semiconductor industry manufacturing. They also have waste and aluminum, also very pure, so they can combine this kind of two waste, become ammonium sulfate. Ammonium sulfate is kind of fertilizer, so this is good. They produce this, and but fertilizer usage, we have some regulatory barrier for this kind of reuse, because the agriculture department, the regulation says nothing can put into the fuel, the farming fuel, because they come from waste. So even they are pure, they cannot put into the farm. So this is the problem. So 1.0, 2.0, we become, say, okay, 3.0. 3.0 is the, okay, since we have problem, we have to solve the problem. So in this kind of problem, we just say, okay, we recycle it and we lease the chemical, leasing the sulfuric acid. So we have a company established about 4 years ago, like SAR, the spent acid recovery technology. So so they will do cracking and burn the acid and to a clean one, and become a new electron grade sulfuric acid to the company, to the semiconductor company, and they will use this kind of material. You see, I would say in manufacturing, they need how clean is the sulfuric acid to become an electronic grade, because their pollutant can be less than, to a very low content, like a PPT level, dozen PPT or several PPT level. It's PPT level. And after the usage of the semiconductor, it becomes PPP level, part per billion, part per trillion to part per billion. So it's very clean also. But the market of the industrial grade sulfuric acid is full. So we use this on the upper left side. You can see the cracking of the circular sulfuric acid, and then the cleaning and dewatering and conversion into sulfuric acid, and then become a new one. So they make it circle, and that would be a very good benefit. They can also reduce the waste, because the waste is no longer waste. They have weight acid. Now they are material, because the material is leasing from SAR, and they don't don't have any reason to treat the waste, and then become resource again. So again, and in the same category, same level of cleaning is central grade of the electronic grade sulfuric acid, and also have the benefit of the water eliminate 18.8%, and also carbon emission is reduced to 36% in comparison with other treatment method. So this is very good. I think it's a very good example to people to know that the not only the municipal family use of the material can use new business model, even chemicals can use a new business model. So business model is the core concept of the circular economy, not only from resource recycling, because resource recycling at that time you treated only part of the problem. We have to make a bigger one. We have to treat with the in Taiwan. We have to treat with 300 million tons instead of 30 million tons of waste. So this is the whole concept of circular economy.
Wonderful. Thank you very much. There are many inspiring examples, including from food or the applications in different sectors. And like you said, the business model is, or rethinking about this process is a very crucial factor in facilitating the formation of the circular economy. You quoted a lot of examples and practices from Taiwan. So for my last question for you, sorry, I've been asking a lot of questions.
Okay.
For my last questions for you, do you think these methods are applicable or replicable in other places, in places other than Taiwan, especially when our audience from the APO community, it's mostly from fast-growing Asia Pacific countries? Would you mind sharing your thoughts about how these practices or methods can also be applicable in other places?
Yeah, I think it's applicable. Talking about the technology, because the technology is worldwide, so it's not a problem. It can easy transfer by from Taiwan, or by this kind of concept. You can develop your own system of the tracking, transparent system. It is okay. The most important one is the I think this is a condition. You have to, it is difficult. You have to have a very good database. You have to know what kind of material. You can solve it, think it as a whole, the whole problem, the whole material input in Taiwan. So the material flow analysis should be the first thing to do. Okay, to do that, and you know your whole system is, no matter what kind of level in detail you are, you can always do the management and digestion and circulation and value added process. That will be the fundamental one, and this is conditionally. Normally in Taiwan, we have a very good advantage because we have a very good system of regulation of reporting. So the company, we have 85% of recycling rate at industry because the regulation want them to report. The regulation doesn't say 85% of recycling rate, but it does say you have to report your waste. How is it treated? How much is treated? And also how much is recycled and how much is disposed. So this is very good way to know that. But so far as I know, many countries doesn't have such kind of regulation. So, but everybody has their own system of database. They know what they're importing, what they're exporting. So this kind of material data is also important. They only have to establish the waste side, because in the whole economics system, the side in Taiwan is about 300 million tons. but the waste time is only 30 million tons. So they only lack of this. So I think it is not hard, but although it's not so easy, but it is reachable a goal to do that from this perspective of view to introduce this kind of system into each country to do that. I think it's possible.
Wonderful. Thank you very much for taking the time to share with us. I really appreciate that today. Ray managed to use the last hour to explain to us the concepts and practices of the circular economy. And also at the end, he gave very practical suggestions and strategies for our audience in different places. So I hope to take this opportunity to thank Ray again for taking the time to share with us. And hopefully there is something interesting and fun for our audience. And if you want to learn more about the practices, well, do get in touch with us or with E3 maybe, see their practices and strategies and technologies. APO does a lot of different activities like multi-country, in-country activities to raise awareness about the green productivity initiatives, including the practices of the circular economy. If you are interested, do get in touch, and hopefully we have another occasion to share with you. And meanwhile, please also stay tuned with our other P-Talk sessions. Hopefully there will be something interesting for you too. If you like this video, please like it, and feel free to subscribe to the APO P-Talk channel. I hope to thank you for your attention for this P-Talk, and also again for our speaker, Mr. Ray Reu from E3, from the RC. Thank you very much, and we look forward to seeing you or meeting you somewhere else another time. Thank you very much. Thank you, Ray.
Bye.